Hello everyone. This video will demonstrate our project for our microcomputer engineering course. We built a device for helping people with visual impairments so they can have more information about their surroundings. This device consists of multiple sensors that serve various purposes. Our device is called TechAid, and here are some of the components that we used in this project. This is the circuit configuration for the GPS, the SD card, and the speaker. The temperature sensor will be demonstrated in the next figure, because at the end of our design, we ended up placing it in this circuit so the speaker can output the temperature and humidity values. Let's now take a look at the code.
So this is the code for the circuit I showed you before. The first step is to include the libraries for the main components, which are the ones for the GPS, for the SD card reader module, and for the temperature sensor. Then we have the basic setup, and then we have the main code. So the first step is just some definitions and methods for the GPS to calculate the time. And then we define the states of the two switches we're going to have. One is for the temperature and the other one is for the time. So first we analyze the time. When the switch state is high, that means when the switch is pressed, we're going to read the temperature, we're going to convert the file to a character, and then we're going to play it on the speaker. For the other button, when it's high, that means when it's pressed, the process is very similar. We play a short introduction, and then we convert the hours and minutes, which are numbers, into characters, and then we play them on the speaker as well.
This configuration is for the DHT11 sensor, the ultrasonic sensor, the piezo buzzer, along with two push buttons. Each button serves a different purpose. When the first button is pressed, the DHT11 displays temperature and humidity values of the room that the device is in. When the second button is pressed, the distance of an object facing the ultrasonic sensor is outputted, and if it gets close to the user, the piezo buzzer goes off and starts beeping. There might seem like there's a lot of wiring in this circuitry, but that's just because the Arduino Nano takes only 2 voltage and 2 ground pins, and since we're working with more than 2 sensors here, most of the connections were made through the breadboards. Let's now take a look at the code. We first include the DHT11 library, and initialize the input pins of the sensors. In the main loop, we set the digital write of the first button to high, and we set a condition for which if it's pressed, the temperature and humidity sensor outputs the values. We then set a condition for the second button. When it's pressed, the distance of an object facing the ultrasonic sensor is outputted, and if it's close to the user by less than 20 centimeters, the tone function of the buzzer is called, causing it to start beeping, and alerting the user that a foreign object is approaching. In case of emergency, a global system for mobiles was used for calling and receiving messages, containing 2 antennas, one for receiving and transmitting signals to the caller ID, and the other one is for determining the user's location. This shield is powered by a 3.7 volt battery. Let's now take a look at the code. First, we include its functions libraries for sending messages along with the GPS, and we also define the shield variables. We define the pins used for calling, and for the setup function, we start by checking if the connections are present. For example, whether the SIM card and the field can get access to the satellite. We then check if the message is received or not. And we define 2 variables for the GPS, which are latitude and longitude. We set them both to type float as they contain decimals, and the character function later converts them from float to character so they can be outputted. The phone double S function allows you to insert the number that you're trying to reach.